In this short series of videos, you will learn how to calculate the crack widths in reinforced concrete structures. The series of videos are all based on the book Structural Design from First Principles, Chapter 10, Control of Cracking in Reinforced Concrete. Cracking is normal in reinforced concrete. If cracks are less than approximately 0.5 mm wide, they will not normally cause corrosion, which is normally caused by the permeation of dissolved salt or carbon dioxide through the cover. Cracking needs to be controlled mainly because it is unsightly and causes complaints. Cracking occurs when the tensile strain exceeds the cracking strain. Tensile strains occur due to loads, shrinkage and temperature changes. The chemical reaction between the cement and the water is exothermic and causes an effect known as heat of hydration, and this causes movements within the first 3 to 4 days, which can induce the initial crack pattern. Winter-summer thermal movements will then widen those cracks, and prolonged shrinkage due to drying will widen the cracks further, in a process that can take up to 10 years. Figure 10.1 here shows you the change in temperature due to the heat of hydration in the concrete. You can see within the first day the temperature builds up and then drops within perhaps 4 days. The temperature rise depends on the size of the member, but in extreme situations it can be as high as 60 degrees centigrade. To work out the strain induced by this change in temperature, we multiply the change in temperature by alpha, which is the coefficient of linear expansion. So we know that the movement is equal to the strain times the length. And if we replace L, the length, by the crack spacing S, we can work out the approximate crack width, W, using equation 10.3 here. So the initial crack pattern widens due to drying shrinkage. Drying shrinkage is due to the loss of water from evaporation, but also water being chemically bonded during the hydration of the cement. That's the process known as autogenous shrinkage. These shrinkage strains widen the cracks formed due to heat of hydration, cracks that are known as the early age cracks. Long-term stress permanently deforms concrete with time in a process known as creep. This can be beneficial because it can reduce cracking due to shrinkage. And figure 10.2 shows you the strain under constant stress versus time. So you can see the initial elastic stress or strain and the long-term creep strains. I hope you found this short video useful. If you want to find out more information, turn to the textbook Structural Design from First Principles. And if you like the video, please also don't forget to press like. Thank you very much for your attention. Goodbye.